Hello everyone, this is Rakesh from Bodhee Prep. I hope you have gone through the previous videos. This is the sixth or the seventh videos, I believe, in the series of number system. And we run online CAT coaching classes. You'll be finding the details in the description if you are watching this in any social media platform, right? So let's quickly start with the process of understanding few terms, which is very, very crucial, not only related to numbers, but it is widely applicable in algebra also, right? So the terms here we'll be understanding today is factors or divisors. Both have usually the same meaning, right? And the meaning of getting the product, right? The product itself, I believe that all of you must be knowing it. Product is nothing but multiplying any two things, right? If it say that get the product of A and B, if it say that get the product of A and B, that simply means that we have to multiply A and B. If it say that get the product of A, B, and C, then we have to multiply all the three numbers. This is the simple meaning of product. But because it appears in the questions, I thought that let me introduce this term and its meaning. We'll be primarily focusing on factors and divisors, and then we'll be extending this logic to understand how prime numbers and what are prime numbers and how prime numbers are closely related to factors, right? So what is factor? So let us first of all find some factors of a number, and through that only we'll be understanding the definition of it. Say I have a number 6. Can I write 6 as a product of two numbers? Product in the sense I need two numbers. The product of it, the multiplication of it should be equal to 6, right? So by usual hit and trial, I can say that this is nothing but say 1 into 6. Why I'm writing this? Because anything multiplied by 1 is same, because when we multiply something with 1, it is neither increasing it nor decreasing it, right? So 6 can be written as 1 into 6. We can also write it as 2 into 3. Correct? There are various ways wherein I can write product of two number which is equal to 6. But right now we are focusing on those numbers which has to be non-negative. And more closely, I can say that only positive integers. We are focusing on only positive integers, the product of two positive integers for which it should be equal to 6. So can I say these are the only two possibilities wherein I can write 1 into 6 and is equal to 6 into 1, right? So just by taking their arrangement differently will not make the two different numbers being the product of product of two different numbers equal to 6 will not make it the difference, right? So here you might be worrying that 1 into 6 is one way. Can't 6 into 1 be the other way? The answer is no, because we need two different numbers. In which order we are multiplying, that doesn't matter, right? So that's why 1 into 6 is as good as 6 into 1. Similarly, 2 into 3 is as good as 3 into 2, right? So these are these four different numbers which we see, which is appearing in the product of taking product of two numbers to get the value 6, right? So these numbers are called factors of 6. These numbers are called factors of 6. So what are factors? If I can take any number A, right, and it can be written as x into y, then x and y both becomes factor of that number A. This is the relationship. So what does this factor do? Factor signifies that if I take any of these factor and divide with the number, right? Suppose if I divide it by 1, then I can say that it will go by 6 times and I'll be getting remainder 0. Similarly, if I take the second factor and divide it 6 with the second factor, which is 2, then we can say that 2 3 times will be getting 6 and the remainder is 0. Similarly, for the third one, it will be the same. 3 into 2, 6 times will be getting the remainder 0. And the last one, 6 itself, can be written like this to get the remainder 0. So in each of these cases, if this is the factor of 6, in each of these cases, when we divide the number by its factor, we will be getting the remainder 0. So we can say that these numbers are also divisor of 6, right? So I hope you have got the relationship between factors and divisor. We can use the word interchangeably, but this is how they are closely related. Now, for 6, we have got the factors to be 1, 2, 3, and 6. Let us take some other numbers. Let us take the number, say 12. So for 12, we can write 12 as 1 into 12. This is one way. Then 2 into 6 is another way. 3 into 4 is the another way, right? Further, there is no other way wherein we can take it as two positive integer, product of two positive integers, right? So if I just observe, then we can say that each of these numbers which are appearing like 1, 2, 3, 4, 6, and 12. These numbers are factor of 12, right? Similarly, if I take the number say 30, in this case, it can be written as 1 into 30, then 2 into 15. We can also write it as 3 into 10, right? It is not divisible by 4, so we can't use 4. Next is 5, so it can be written as 5 into 6, right? Now further, we'll be getting the same kind of product. The only thing is that the numbers will, the order will change. So again, if I collect all the factors, then it is 1, 2 is there, 3 is there, 4 is not there, but 5 is there, 6 is there, as we can see. 7 is not there, then we are getting directly 10. Then after that, we are directly getting 15, and then we are getting 30, right? So likewise, we can get the factors of all the numbers. Now, if you closely observe, then we can say that 1 is appearing every time. 1 is appearing every time. That means 1 will always be the factor of all the numbers. 1 is factor of all the numbers. That's what we can say, right? Next is the number itself is also appearing. The number itself is also appearing because it is getting paired with 1, right? So we can say that the number itself will also be the factor of the number, right? The number itself is the factor of itself, right? So these two are common. Rest will depend upon what is the number and with which number it is getting divided, right? Fully divided in the sense the remainder should get will be getting we should be getting remainder as 0, right? So this is all about factors. Now, how prime numbers are related with factors? Let's see that. So what we will do is that we'll be taking factors of the first 20 numbers. Let's see that. Let's take the process from very elementary this way. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Next, I'm writing 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. What I'll do is that I just want to factorize them and try to figure out that in how many different ways these can be written as factor of two numbers. One, there is no other possibility rather than just writing 1 into 1, right? For 2, we have no other option but writing it as 1 into 2 because there is no other two positive integers whose product is 2. We don't have to take root of 2 into root of 2 because root of 2 is an irrational number, right? We have to take positive integer. 3, again, we have only this option. For 4, we have this option and we have this option as well, right? So there are two different ways wherein I can write the product of two numbers which will be equal to 4. For 5, again, I don't have any option. You can check on yourself, right? For 6, we just saw that there are two different ways. For 7, again, we don't have any option. For 8, we have the option 1 into 8, or it could be 2 into 4, right? For 9, we have 1 into 9, or it could be 3 into 3. For 10, we have 1 into 10, or it could be 2 into 5. For 11, we have no other option but to write 1 into 11. For 12, we have more than one option, obviously. This and this and this. Correct? For 13, we have no option. For 14, we have more than one option. For 15, we have this option, this option. For 16, we have this option, as well as this option, 4 into 4. For 17, we don't have any option. For 18, we have this option, right? We have this option as well. For 19, we don't have any option. For 20, we have 1 into 20. It could be 2 into 10, right? It could be 4 into 5. Correct? So if you observe closely, then we can say that for 1, there is only this way of writing, wherein there are no two different ways, or there are no two different numbers wherein we can take for which the product is 1. So ignoring this one, if I observe 2, 3, 5, 7, right? 11, 13, 17, and 19. If I observe this, then we can say that the number of different factors in each case is 2. In this case, it is 1 and 2. In this case, again, it is 1 and 2. In this case, again, 1 and 5. In this case, again, 1 and 7, right? In this case, again, 1 and 11. In this case, again, 1 and 13. In this case, again, 1 and 17 only. In this case, 1 and 19 only, right? Let me check whether I have taken all those numbers or not. Okay, right? Apart from that, for every other numbers, you can see that there are more than two factors which the number has. For example, 4 has 1, 2, and 4. 3 factors. That means more than 2. For 6, it is 1, 2, 3, and 6. There are 4 different numbers or 4 different factors. For 8, again 4 different factors. For 9, 3 different factors. For 10, 4 different factors. For 12, 1, 2, 3, 4, 6, and 12. That means 6 different factors. For 14, 4 different factors. For 15, 4 different factors. For 16, again 6 different factors. Sorry, 1, 2, 3, 4, and 5. 5 different factors, I would say. For 18, 1, 2, 3, 4, 5, and 6. 6 different factors. For 20, 1, 2, 3, 4, 5, and 6. Again, 6 different factors. Only in case of 2, 3, 5, 7, 11, 13, 17, and 19, we are getting the number of factors to be 2. Such numbers are called prime numbers. So if you want to define what are prime numbers are those numbers which has only 2 positive integral factors. That's one way of defining prime numbers, right? Because they are not divisible by any other than 1, other than by itself, and 1 they are not divisible. That's why we call them prime numbers. Getting it, right? Rest all numbers, what do I call? We call all other numbers to be composite numbers, right? These are prime numbers. So for composite numbers, number of factors will always be greater than 2. Number of different factors for composite number will always be greater than 2, right? I need not to say that every time the factor has to be positive integral, because when we say factor, it is understood that we are talking about positive integer, right? But what about 1? The number of factors of 1 is 1, right? Other than 1, there is no factor of 1. Right? So it is not coming in the definition of prime number, neither it is coming in the definition of composite number. For prime number, the number of factors has to be only 2. For composite number, the number of factors has to be greater than 2. For 1, the number of factors is only 1. Right? So by definition, we say that 1 is neither prime nor composite. Right? This is by definition. Because to be a prime number, it has to have 2 factors. And to be composite number, it has to be a factor greater than 2, right? So I hope you have understood what are prime numbers. Now let us take a few questions which are primarily based on factors and prime number. They are all elementary, but they will help you that how these concepts are used, right? So let me take one. In fact, there is one more observation. If you observe closely, I just missed that. Let us observe closely that barring 2, all other prime numbers are odd, right? There are infinite prime numbers, right? The number of prime numbers is not finite. There are infinite prime numbers. But barring 2, all other prime numbers, even if you move till say 100 and etc., you will find that all prime numbers are odd numbers. And that is a fact. Why so? Because any other even number other than 2 will have a factor more than 2. Why? For example, if I take the number say 60, other than 1 and 60, 2 will become the factor because every even number is divisible by 2. When it is divisible, that means 2 is a divisor. If it is a divisor, it's a factor as well, right? So barring 2, all even numbers will have more than 3 factors, or sorry, more than 2 factors. And because they have more than 2 factors, they can never be a prime number. So we are very sure that no even number other than 2 would be a prime number. So for prime number other than 2 has to be an odd number, right? Or we can say that 2 is the smallest prime number, right? As well as only even prime number. Only even prime number. That's what we can say, right? So this was just by observation. It is very, very crucial. We'll be using it, right? So let's take few examples. So I have written one of the questions here that we have to find all factors of number 40, right? There is a formula for it also to find the number of factors. I'm not going into details of it because I want that you should understand right from the very basic. Can you write all the factors? Let's see that because that is very, very important. So 40, I can write it as 40 into 1, right? Or we should write it as 1 into 40 so that we can keep on increasing the factor 1 into 40. Now, after 1, can I write it as 2 into something? Yes, because 2 is a even number, 40 is also a number. So 2 will divide 40 for sure, which is equal to 20. Then 3, can I write it as 3 into something? No. Why? Because 40 doesn't appear in a table of 3. So definitely 3 will not be dividing 40. Can 4 divide 40? Yes. 4 into 10, right? Can 5 divide? Yes, because 40 appears in a multiplication table of 5, right? Can 6 divide it? No. Can 7 divide it? No. Can 8 divide it? Yes. But 8 we have already used it, right? So the next number would be what? If I write it 8, it will appear 8 into 5. But that factors we have already taken. The order doesn't matter. So if you reach this particular stage, then you can say that you have considered all the possible factors. So you have to start from 1 and you have to go till that number wherein the repetition of the factors start appearing. Then you will be very sure that you have considered all the possible factors. You haven't left anyone. Now just count the numbers. The factors are 1, 2, then 4, then 5, then 8, then 10, 20, and 10, 20, and 40. Right? If you count them, then you can see that the total number of factors is 8, and these are the factors of 40. Right? If we just needed this one, how many factors of 40 are there? We have a direct formula. We'll be dealing it in some other video. But right now, I'm more interested in that. Can you write all the possible factors? Right? Because once you can do this, that means you will also be understanding the formula and you'll have more depth understanding about the factors rather than having a superficial formula based understanding, right? Okay. What is my next question? So the next question is that we have to find all prime numbers from 1 to 100, right? All prime numbers. Now let me tell you that there is no formula to find prime numbers, right? There is no formula to find prime numbers. They are randomly distributed throughout the numbers, right? And there are infinite prime numbers. So it is not so that there are limited number of prime numbers, correct? So we have to apply the logic of prime numbers to identify them, right? So let's start with 1. 1 is neither prime nor composite, done. 2 is the smallest prime number, we just saw. 3 is also prime number, 5 is also prime number, right? 7 is also prime number. So here what I'm doing is that barring 2, I'm leaving all even numbers because no even numbers will be a prime number. So I'm just counting the odd numbers. So from 100, 50% of, or sorry, half of the even numbers will be ruled out. Only odd numbers will be taken care, right? Next odd number is 9, but 9 is divisible by 3, so it's not a prime number. Next is 11. Yes, 11 is a prime number. 13 is a prime number. 15 is not a prime number because it is a multiple of 5. It is divisible by 3 as well. 17 is a prime number. 19 is a prime number. 21 is not a prime number. It is divisible by 3. You can see that 3 into 7 is 21. 23 is a prime number. 25 is not a prime number. It is divisible by 5 as well, right? 27 is not a prime number or divisible by 3, right? So apart from 1 and 27, we have other factors. So it has more than one factors. Sorry, more than two factors. Then next is 29. Yes, 29 is another number, correct? Then 31 is another number. 33, we have to rule out. It is divisible by 3, right? And 11 as well. Then next is 35 ruled out. 5 se divisible hoga. 37 we have to take. Then for 39 has to be ruled out because it is divisible by 3. Then 41, 43 has to be taken. 47, 2 has to be taken. 49 has to be ruled out. 51 divisible by 3. 53 is not. Then 55 is ruled out. 57 is also divisible by 3. 59. Right? Then 61. 63 is ruled out, divisible by 3. Right? 7 into 9, in fact, divisible by 7 also. 67 we have to consider. 69 is to be ruled out. 71 has to be taken. 73 has to be taken. 79 has to be taken. Right? So I'm just moving away. 81 is ruled out. 83 has to be taken. 89 has to be taken. Then 91 is not, yes, it is divisible by 7. 93 is divisible by 3. 97 will be divisible by, will not be divisible by any of the numbers. Now, if you count them, then let's see whether I have counted, I have taken all the prime numbers or not. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Yes. So these are the 25 prime numbers from 1 to 100, right? So this you need to remember, because many a time the initial few prime numbers are very, very important. So need to identify that whether this number is prime or not, right? At times, many of you feel like that 91 is a prime number, but it is not, because this 91 is nothing but 7 into 13. So please ensure that this should not be considered a prime number, right? Okay, now let's take the next set of question. The next thing is that the question is sum of two prime numbers is 85, right? Find the product of those two prime numbers, right? Now, how do I identify that which two prime number is equal to 85? The catch here is that this number is odd. This number is odd. Now, if this number is odd, I'm adding two number A and B, and this is equal to odd, right? What can we say about A and B being even or odd? Can I make any kind of assessment? Let's see. If I take two odd numbers, for example, 3, and the other odd number is 7, I'll be getting 10. So can I say two odd number sum is giving me even number, right? This will always happen. You can check on your own. If I take one of them to be even and the other to be an odd number, I'm getting an odd number, because this is odd, this is even, right? If I'm taking both to be an even number, then the result is also an even number, correct? So can I say, observing this, the question is about this condition, wherein the final value is odd number. The final value is odd number. So A plus B is equal to 85, and both A and B have to be prime number. This is an odd number. So can I say one of them has to be an even number and the other has to be an odd number? Even prime. Which one is the even prime? 2. There is no other prime number which is even other than 2. So can I say one has to be 2, other has to be, say, B. This should be equal to 85. If we want to find the value of B, it should be equal to 83. Yes, 83 is a prime number. We just saw. I wrote all the 25 prime numbers for you. 83 is a prime number. So now we have identified both the prime numbers. One is 2 and other is 85. 83. The other is 83, and we have been asked about their product. Now, what is product? Product means their multiplication. So we have to multiply them. So the answer would be 166. So this becomes your answer, right? These are very, very elementary questions. But the good thing is that we have understood what are factors and how factors and divisors are interrelated. We saw that what do we mean by product as a word in mathematics. Then we saw that how the number of factors is responsible to categorize the number being prime or composite. If the number of factor is equal to 2, the number is prime. If the number is factor is greater than 2, then it's a composite. And number one is such number which has only one factor, so it is neither prime nor composite. Within prime, we saw that 2 is the only even prime. Rest all prime has to be an odd number. There is no formula to calculate any prime number or generate prime number, right? They are randomly distributed throughout the numbers, and there are infinite many prime numbers. Initial few prime numbers are of importance to us, right? And with the help of few examples, we also understood that if a question appear related to prime number, then we have to actually apply the observation related to prime numbers, right? And we saw that how the factors are calculated. In the coming classes, we'll also be seeing that how the number of factors, HCF, LCM are used, right? Or the prime factors are used. So the last topic, which is yet to be concluded, is prime factorization. So let's see that, and then we'll be done for this video. So let us understand what is prime factorization. So we understood what is factor. we understood what is prime. So prime factorization in the sense, whenever a number is broken into factors, all those factors has to be a prime number, right? For example, 6, the number of way I can write 6 is 1 into 6. The other way is what? 2 into 3. This will be ruled out. This is the prime factorization. Why? Because both these factors are prime number, right? Both these factors are prime number, and every composite number can be broken into product of prime numbers. Let me repeat. Every composite number, 6 is a composite number, right? Every composite number can be broken into product of prime numbers. Let us take some other examples. Say 30. It can be written as 2 into 3 into 5. Yes or no? You can just cross check. 2 into 3 is 6. 6 into 5 will make it 30. So this way of writing the product of any composite number, wherein all these numbers are prime, we call the process as prime factorization. Right? Now, what is the best way to do prime factorization? It's a long division method. Very simple. You must have heard about it during your school days. For example, I want to get prime factorization of number 30. So what I'll be doing is that I'll start with the smallest prime number 2. This is given. So I'll divide this 30 by 2 and we'll collect the quotient. Quotient in the sense 2 into what will give me 30? Of course, it is 15. Very simple. Next, is this number again divisible by 2? No. Why so? Because this is an odd number. So we'll be considering the next prime number. Is this number divisible by 3? Yes. 3 into what will give me 15? Yes, 5 times. Right? Now again, is this number divisible by 3? No. So we have to look for the next prime number, which is sorry, 5. How much? 1 time. Right? So we have to follow this process till we get 1 at last. So then this number 30 will be product of all these numbers. That is what written here. Correct? Let us take one more example, 90. I want to prime factorize it. Also to start with 2. 2 into something give me 90. So we have to just basically half 90, get the value which is half of 90. So it will be 45. This number is now not divisible by 2. Is it divisible by 3? Yes. 3, how many times is equal to 45? 15 times. Right? 3 1 ja 3. 1 carry forward 15. It will go by 5 times. Again, it is divisible by 3 now. So we'll keep on dividing it by 3 till we get a number which is now not divisible by 3. It is again 5. This is 5 1 times. So product of all these 3 numbers, 2 into 3 into 3 into 5 is equal to 90. You can cross check also, right? What is a better way of writing this? Because 3 is repeating twice. So better way of writing this is 2 into 3 to the power 2 into 5, because we have understood what this power means. 3 to the power 2 means what? 3 is multiplied twice, right? Let us take for 120, 2 60 times, 2 again 30 times, 2 15 times, 3 5 times, 5 1 time. So product of all this. So 120 is written as 2 into 2 into 2. How many times? 3 times. So we can write it as 2 to the power 3 into 3 into 5. This is the prime factorization of 120. Right? So I hope you have understood what is prime factorization. So with this, we'll just rest this video here only. In the next video, we'll extend the logic of prime factorization to understand how do we calculate HCF and LCM.